Hello everybody, welcome into another lesson. So today we are going to talk about solving quadratic inequalities algebraically. So much like we have linear inequalities, you can have quadratic inequalities. You can have inequalities to any power, or even rational ones, or other types of inequalities. Well, how would you approach a quadratic inequality? For example, here we have x squared plus 3x minus 18 is greater than or equal to 0, right? How would you approach that? For any inequality, you want to treat it like it were equal to 0, which means you're going to want to factor this. So let's factor this out. That would definitely factor into x plus 6 times the quantity of x minus 3, which would of course be greater than or equal to 0. So now pretend like this is an equality equal to 0. Just set each of your x factors equal to 0. So x plus 6 equals 0 would give you x equals negative 6, right? Then you have x minus 3 equals 0, which means x equals 3. And these will be part of your solutions, but it's not just about what's equal to 0, it's also about what's greater than 0. So how do you handle that once you factored and found your solutions? You're going to draw a number line. That's the exact thing you would like to do next, is draw a number line. But it doesn't have to be a bunch of points. All you need on your number line are your two solutions to x. So your negative 6, your positive 3. Put those on your number line. All we're testing for now to see in what intervals is it true that this equation is greater than or equal to 0. So what if we went from negative infinity to negative 6? Every point to the left of negative 6, right? Pick any point in that interval. As for me, I'm going to pick negative 7. I think that's a great one to pick. So what if we pick f of negative 7? Well, f of negative 7, it's easier if you put it into your factors. That would be equal to negative 7 plus 6 times the quantity of negative 7 minus 3. Well, that would end up giving you, of course, negative 1 times negative 10, which would end up giving you positive 10. And we know 10 is greater than 0, right? 10 is greater than or equal to 0. So that meets the criteria. The interval from negative infinity to negative 6 is positive, because really we're looking for positive values if it's greater than 0. Now, we got to pick a number in the interval between negative 6 and 3. Let's pick 0. Pick any number in that interval. So again, put it into your factors because it's easier. You'll have 0 plus 6, that quantity, times 0 minus 3. Well, that's just going to turn into 6 times negative 3, which would give you negative 18. Well, we know negative 18 is certainly not greater than or equal to 0. It's not greater than or equal to 0. So that'd have to mean it's negative because we're looking for positive values. So you'll put a negative sign in that interval. So this interval in between negative 6 and 3 definitely won't work. Now we need to test to see 3 and greater. Would that interval work from 3 to infinity? Pick any value greater than 3. So let's pick f of 4. F of 4, that's going to equal, of course, put it into your factors. So you'll have the quantity of 4 plus 6 times the quantity of 4 minus 3, which would end up equaling 10 times 1, which would equal 10. Well, we actually do know that 10 is greater than or equal to 0. It's a positive result, so from 3 to infinity works, okay? So we're looking for positive intervals to solve this. Well, since it's greater than or equal to 0, it's going to be negative 6 inclusive. So you could start out by listing it as x is less than or equal to negative 6 and x is greater than or equal to 3. Which, that's one way, but now that we're in Algebra 2, I want to get you used to what's called interval notation. It's important we start getting used to that, because as we get higher up, you're going to start seeing this in interval notation. Well, if x is less than or equal to negative 6, that's going to go from the interval negative infinity, where it starts, always with a parenthesis, because it can never truly be equal to negative infinity, to the number negative 6. So negative infinity, comma, negative 6. Now, since that negative 6 is included in the solution because of the equal part, you'll put a bracket around the negative 6. So in negative infinity or infinity will always have a parenthesis. We can never equal infinity because, again, it doesn't have a defined value. But if the negative 6 in this case is included in your solution set, you'll put a bracket next to the negative 6. If it wasn't included, you would put a parenthesis. And then you'll put the U for in union to indicate we have two sets in union, where 3 is also included in the solution set. So you'll put a bracket around the 3 to comma infinity with a parenthesis, since we can't really include infinity, but that's the answer we'd be looking for interval notation. Negative infinity to negative 6 inclusive, that set in union with the set of 3 inclusive to infinity. That's the answer you should get. Those are the intervals which will solve this inequality. And I got more. All right, what if we have we have 3x squared minus 16x plus 5 is less than or equal to 0. So we have 3x squared minus 16x plus 5 is less than or equal to 0. Well, this time we're definitely looking for negative solutions, but the process is still the same. We want to factor this. So this will factor into, of course, you'll have your x, then you'll have your 3x. All right, and then, let's see, this will be minus 5 minus 1. Okay. So this would factor into the quantity of x minus 5 times the quantity of 3x minus 1 is less than or equal to 0. Now, like before, you'll take each of these and set them equal to 0. X minus 5 equals 0 would simply give you x equals 5. And then 3x minus 1 equals 0 would give you 3x equals 1, which would give you x equals 1/3. So we have two values of x, being x equals 5 and x equals 1/3. Since this is less than or equal to, both of those values of x will be part of your solution set. So let's go ahead and draw ourselves a number line with those two numbers. So we had x at 1/3, and then we had it at 5. So now we need to test intervals to see which ones create the solution less than or equal to 0. So let's put in, we need to go from negative infinity to 1/3. So any number less than 1/3, we'll go with 0. How about 0? So if I put in 0 into my factors, so f of 0 would end up giving me the quantity of 0 minus 5 times the quantity of 3 times 0, that's just 0 minus 1. What's that going to give me? Negative 5 times negative 1, which would give me positive 5. Well, positive 5 is certainly not less than or equal to 0. It's actually greater than 0, so you'll put a positive sign here. Now we need to test the interval between 1/3 and 5. Put in any number between 1/3 and 5. Well, f of 1, that's a good place to start, right? F of 1, so that will give you in your factors, you'll take 1 minus 5, that quantity times 3 times 1 is just 3 minus 1. So that's going to equal, of course, negative 4 times 2, which would give you negative 8. Negative 8 is definitely less than or equal to 0. That checks out, so that's negative. And we're actually looking for negative solutions this time, since the inequality is less than or equal to 0. Now, of course, we got to test the interval from 5 to infinity. So let's put in f of 6. F of 6 is going to equal the quantity of 6 minus 5 times the quantity, what's 3 times 6? That'd be 18 minus 1. So this would turn into 1 times 17, which would give you 17. Well, 17 is definitely not less than or equal to 0. It's actually greater than 0, so put a positive sign for that interval. Now, we're looking for negative solutions because it's less than or equal to 0. The only interval that satisfies that is from 1/3 to 5, both of those inclusive because of the equal part. So the interval that satisfies a solution would be 1/3 inclusive to 5 inclusive. And you'll have brackets around both because those are actually included in your solutions. So the interval from 1/3 to 5, both inclusive, would satisfy this inequality. All right. Got a few more here. I have about 4 more. So let's see. Good one. 4x squared is less than 25. So we have 4x squared is less than 25. Now, if it were just 4x squared equals 25, we could solve this by doing the square roots method. Whenever you have an inequality, you always want the right side of the inequality to be 0. Always. So first thing I'm going to recommend is now we turn this into 4x squared minus 25 is less than 0. Now we have an inequality we can work with. 4x squared minus 25 is less than 0. Well, here's the thing. We have no equal component. We just have a less than, only less than. So we're looking for negative values. So still your approach is going to be treat this like an equality at first and factor it. Clearly we have a difference of 2 squares, right? So this will factor into 2x plus 5, that quantity, times 2x minus 5 would be less than 0. Then just take each of your factors, set them equal to 0, so 2x plus 5 equals 0. Well, that would give you 2x equals negative 5, which would give you x equals negative 5 halves. And then take your 2x minus 5, set it equal to 0, which would give you 2x equals 5, which would give you x equals positive 5 halves. So you got x equals negative 5 halves and positive 5 halves. However, it's just simply less than 0. There's no equality component, so these two numbers will not be included in your solutions. But still the same process. Set yourself up a number line. set yourself up a number line here. So we'll take the negative 5/2 for one part. Then we'll take the positive 5/2 for another part. Now we need to test intervals to see where is this inequality less than 0. Where is it negative, in other words? So take any number less than negative 5/2, which we could do f of negative 3. So if I put in f of negative 3, put those into your factors, well, 2 times negative 3 is negative 6 plus 5. That quantity times 2 times negative 3 is negative 6 minus 5. Well, this is going to end up giving me negative 1 times negative 11, which gives me positive 11. Well, 11 is clearly not less than 0. It's actually greater than 0. 11's not less than 0. It's actually greater than 0. So we'll put a positive sign here to indicate from negative infinity to negative 5/2. Next, what we need to do is test the interval between negative 5/2 and 5/2. F of 0 is a great place to start, right? F of 0 would equal, in your quantities, in your factors, 2 times 0 is just 0 plus 5, times then you have 2 times 0, which is just 0 minus 5. Well, this would just turn into 5 times negative 5, which is going to give you negative 25. Well, it's clear that negative 25 is less than 0, which is what we're looking for, right? Negative 25 is less than 0, so put a negative sign there. And then we have to test the interval from 5/2 to infinity. So pick any number greater than 5/2, which we'll pick f of positive 3. So f of 3 would equal, in your factors, 2 times 3 is 6 plus 5 times the quantity you have in your other one. 2 times 3 is 6, then minus 5. So you end up getting, this would turn into 11 times 1, which we know is positive 11. Well, 11 is definitely not less than 0. It's greater than 0. So put a positive sign there. Since the inequality is less than 0, we're looking for the intervals where this is negative. It's going to be in the interval between negative 5/2 and positive 5/2. And since it's just less than, we do not include the negative 5/2 and 5/2. So how you'll denote that is parentheses around both. So parenthesis negative 5/2, comma, 5/2, comma, parentheses. That would be the interval that satisfies this inequality. So from negative 5/2 non-inclusive to positive 5/2 non-inclusive, because they have parentheses around them. And I got about 3 more. All right. Negative x squared minus 12x is less than 32. Good one. So we have negative x squared minus 12x is less than 32. Well, again, the rule is you want to get your right-hand side of the inequality always 0. So I'm going to suggest we subtract 32 from both sides. You'll end up getting negative x squared minus 12x minus 32 is less than 0. Now here's the thing. You always want, even to factor, you always want your coefficient on the x squared term to be positive. It doesn't have to be 1, but it's got to be positive. So we need to factor out negative 1, right? So this will turn into negative of the quantity of x squared plus 12x plus 32 is less than 0, which means we got to divide both sides by negative 1. What happens when you multiply or divide both sides of an inequality? It flips the sign, if we remember that. So this would actually turn into x squared plus 12x plus 32 would be greater than 0. Because when you multiply or divide by a negative, it flips the inequality sign. Now we just need to factor this in general. This will factor into the quantity of x plus 4 times the quantity of x plus 8 is greater than 0. Then you'll just, of course, you're going to take each of your factors, set them equal to 0. You would just get x equals negative 4 and then x equals negative 8. But since these are only greater than 0, there's no equal part. These two numbers will not be included in your solution set. So now it's time to set up another number line with both of those numbers. So let's take negative 8, the smallest number, and then let's take negative 4, the bigger number. So we need to test the interval from negative infinity to negative 8. Do we get a positive result? So it's supposed to be greater than 0. Well, let's take f of negative 9. Let's do f of negative 9. We'll find out. So f of negative 9 would equal the quantity of negative 9 plus 4 times the quantity of negative 9 plus 8, which would end up equaling negative 5 times negative 1, which would actually equal 5. We know 5 is greater than 0, so that checks out. 5 is greater than 0, it's actually positive. That checks out. Next, we need to test the interval between negative 8 and negative 4, so pick any value between them. We'll do negative 6, since it's in the middle. So f of negative 6 would end up equaling your factors here. You end up having negative 6 plus 4 times the quantity of negative 6 plus 8, which would end up giving you negative 2 times positive 2, which would give you negative 4. We know negative 4 is not greater than 0. It's definitely not greater than 0. It's actually less than, so you'll put a negative symbol there above it. And then last but not least, we need to test the interval from negative 4 to infinity. Pick any number. Pick any number at all. I'm going to pick f of 3. I'm sorry, f of negative 3, excuse me. So f of negative 3 would equal in your factor, so you'll have negative 3 plus 4 times the quantity of negative 3 plus 8, which would end up giving you 1 times 5, which we know 1 times 5 equals 5, and 5 is clearly greater than 0. So you'll have a positive. So we're looking for the interval since the inequality ended up just greater than, where it's positive. Those intervals are from negative infinity to negative 8, non-inclusive. Since it's just greater, there's no equal to. You're going to take the interval from negative infinity to negative 8. You'll have parentheses next to the negative 8 because it's not included, in union with the negative 4 non-inclusive. So I have a parenthesis next to the negative 4 to infinity. That denotes the two sets of numbers that are the solution. So negative infinity to negative 8 in non-inclusive in union with the set of negative 4 non-inclusive to infinity would be the solution to this inequality. Two more. All right. 2x squared minus 4x minus 5 is greater than 0. So we have 2x squared minus 4x minus 5 is greater than 0. So it's just greater than, there's no equal, but still we start out by factoring this. So let's see how we're going to do that here. Well, unfortunately, if I am looking at this correctly, you can't really factor it. But you could still use the quadratic formula. It's just going to be a little hideous. So let's set up our quadratic formula here. So x would equal the negative of b. What's negative? Negative 4. That's positive 4 plus and minus the square root of b squared. That negative 4 squared is 16 minus 4 times your a of 2 times your c of negative 5 all over 2 times your a of 4, which would end up giving you, of course, 4 plus or minus the square root of 16 plus 40 is what this would turn into, all over 4, which would be equal to 4 plus and minus the square root of 56 all over 4. Well, 56 factors into 4 and 14, so you end up having 4 plus and minus 2 times the square root of 14 all over 4, which would end up giving you a solution of 1 plus and minus square root of 14 over 2. Now keep in mind, these are two different solutions. You have one solution that you have 1 plus the square root of 14 over 2. Then you have 1 minus the square root of 14 over 2. So they're two different solutions. But we're still going to treat this the same. We are going to set up our number line here. So obviously 1 minus the square root of 14 over 2 would be smaller. 1 minus the square root of 14 over 2. And then of course the bigger number is 1 plus the square root of 14 over 2. So we need to figure out our intervals here. Since the inequality is greater than 0, we need positive results. So let's go ahead here. Let's do a little bit of math here. Let's figure out all this disaster. So what is the square root of 14 divided by 2? Divided by 2, and then you have 1 minus, that'd be about negative 0.87 approximately. That has a value of approximately negative 8.7. So let me write that. Negative 0.87 is what that's equal to, okay? Now, let's find any value smaller than that to represent from negative infinity to this value here. Definitely negative 1, right? If I put in f of negative 1, what do I get? Well, f of negative 1 would, we just put this into the original, that would give me 2 times 1 because negative 1 squared is 1 minus 4 times negative 1 minus 5. So this will turn into 2 plus 4 minus 5. 2 plus 4 is 6 minus 5 equals 1. Well, clearly 1 is greater than 0. So this is positive from negative infinity to this answer here. Why don't we get a decimal approximation for this number too, so we know about what we're working with? So square root of 14 divided by 2 plus 1 would give me about 2.87. So that approximates to about 2.87 when you do it. So yeah, we can go with f of 0. That'll work, because that'll be in between these two numbers. So f of 0, that would give you 2 times 0 minus 4 times 0 minus 5. Well, that turns into a whole lot of 0 minus 5. That's going to give you negative 5. Negative 5 is clearly not greater than 0. It's actually less than 0. So you have a negative sign here. And then, of course, we need to find from the interval of roughly 2.87 to infinity. So let's go ahead and take f of 3. That'll be the easiest one to do. 2 times 3 squared, so that's going to be 2 times 9, minus 4 times 3, and then minus 5. So that's going to equal 18 minus 12 minus 5. That would also be equal to 1. Well, 1 is definitely greater than 0, so you'll put a positive sign in that interval. And what we're looking for, since the inequality is greater than 0, is actually going to be positive results. But since it's just greater than, these numbers are not included in your solution. So the solution sets are going to be negative infinity to 1 minus the square root of 14 over 2, non-inclusive, so put a parenthesis around it, in union with the set of 1 plus the square root of 14 over 2, non-inclusive, so put a parenthesis next to that, and then to infinity. So yes, that looks hideous, but that would be your solution set by the quadratic formula. And I do have just one more, then we'll be done with today's lesson. I'll note with inequalities, completing the square really doesn't pay off, because then you would have a number on the right hand side of the inequality which you don't want. So it's either factoring or quadratic formula. It's one or the other with those. Last one, then we're done for the day. So we have half x squared plus 3x is less than or equal to negative 6. So half x squared plus 3x is less than or equal to negative 6. Well, I'm definitely going to suggest we make to the right of the inequality sign a 0, so add 6 to both sides. This will turn into half x squared plus 3x plus 6 is less than or equal to 0. Now we got something we can work with. First thing I'm going to suggest, get rid of your fraction, right? So multiply everything by 2. This will turn into x squared plus 6x plus 12 is less than or equal to 0. And unfortunately, it looks like we're in another situation where we really can't factor. So back to the quadratic formula. So x equals negative of b, so that'd be negative 6 plus and minus the square root of your b squared. So that's going to end up being 36 minus 4 times your a of 1 times your c of 12 all over 2 times your a of 1, so that'd be 2. Well, that would equal negative 6 plus and minus the square root of, well, that'd be 36 minus 48 all over 2. All right, well, here's the thing. For inequalities, we're only concerned with real numbers. If this were an equality, we could not worry about it then. But with inequalities, we're only concerned with real numbers, because 36 minus 48 would give you negative 12. So in this case, you'll just say there's no real solution. There is no real solution to this for the inequality. We're only concerned with real solutions when it comes to the inequality. Now obviously I could just get the equality part and it would be imaginary, but we're concerned with also the less than component, so there's no real solution. So that's it for solving inequalities algebraically. Next lesson we will graph quadratic inequalities. So I hope everyone has a great day. Take care.